Hi, and good morning, everyone. At least it's morning in the UK. Good afternoon if you are in the Far East. I noticed that one delegate is in school in Indonesia at the moment, so I'm guessing it's sometime in the afternoon there. I'm sure you've got much better weather than I've got here. Welcome to this second module, following on from yesterday's module on getting ready to teach Pearson Edexcel International GCSE Chemistry. As Edley said, my name is Cliff Curtis, and I will be your presenter for today. So without any further ado, let's move on to what we are trying to aim for today. So the aims and objectives of this particular session are to understand the question types for this qualification, to understand the assessment objectives for the qualification, to practice using mark schemes, using exemplar student work, to learn about the support provided by Pearson around assessment and exemplar materials. So the session agenda will follow question types, assessment objectives, questions and mark schemes on AO2 assessment objective, and then questions and mark schemes on AO3 assessment objective, and then a quick note about the subject advisor that you can contact should you have any queries about the qualification. So let's move on to the various question types that are present in both of the papers. Yesterday, I went through the type of papers that will be set in both the linear and the modular qualifications. On the exam papers, the same question types will be set in both papers. They'll be absolutely identical. So everything I have to say about question types applies to both linear and modular examination papers. And the following question types will be set in both papers 1 and papers 2, as I said, both linear and modular. There will be multiple choice questions with 4 alternative answers labelled A, B, C, and D. Unlike the international A level, there will not be a separate section of multiple choice questions. The multiple choice will be spread throughout the paper. The idea behind this was to make sure that multiple choice questions were set in the context of the particular topic being assessed in that question, rather than have a bank of multiple choice questions that jump from one topic to the next. We felt at GCSE that that would be a better way of allowing the students to have access to the questions. At A level, it becomes less important, perhaps. There will also be short response questions with a mark range from 1 up to 4. There will be some extended writing questions worth 5 or 6 marks. And of course, there will be calculations. Questions assessing experimental skills will be set in both papers, and the questions on experimental skills could be a whole question targeting experimental skills only, or they could be a part question of a question which is assessing other skills as well as experimental skills. So don't expect to see separate questions all the time targeting experimental skills. You may find that there's a part question of a whole question that's actually targeting experimental skills. Okay, I was just looking at the chat box to see if there's anything I needed to answer to. Okay, multiple choice. Here is a typical multiple choice question. Okay, I remember that this was a question that I wrote quite a number of years ago now. I was the principal examiner for this qualification from 2010 through to the end of 2017. I gave up marking completely in 2018, so just over six and a half years ago. But I remember writing this particular question, and here's a typical question. And the way the candidates have got to answer it is to put a cross in the box. If they feel that they've made a mistake, then they put a line through that particular answer and then put a cross in another box, which they want to be their answer. Should they suddenly put crosses in all four boxes and then suddenly realize, hang on a moment, I made a complete hash of this. The first answer I put down is the one that I really want. Then there's no problem. They just simply put a big letter to the left-hand side of that, and that will be picked up when papers are scanned and can be marked by hand at a later stage. So again, we have fallback measures in place should the candidates make a complete mess of answering a multiple choice question. There's a typical short response question. This one is worth 3 marks, and you'll notice that there's 1, 2, 3, 4, 5, 6, 7 lines left in which to mark it. One of the things that I would suggest that you stress to your candidates is that there is no requirement to fill up all 7 lines. The reason why we give so much space available for a 3-mark question is in case the student starts off making a mistake in their answer, realizing they've made a mistake, and they cross it out, and then hopefully they've still got some lines left available to put in an alternative answer. So that's the reason why so many lines are left. You will see, at least I have seen, a large number of scripts over the many years that I've been marking where it's obvious that candidates have felt that they have to fill up all of the lines available, and they just continue writing. And sometimes actually it hasn't helped them because they write down information that turns out to be incorrect and contradicting some things they've already put down. And that causes them to lose marks. So exam technique is very important here. I can see a number of questions coming up into the chat box here, so I'll just have a look to see, okay, what is the spacing between the lines? The best way of you finding that out is to actually look at a past paper on the website, the Pearson website, and then you will see exactly what the spacing is. I couldn't tell you off the top of my head, okay? Okay, I think, yep, all the other questions have been answered, so I'll move on. Right, that is a typical extended writing question. Again, I seem to be choosing ones that I wrote. This one's got malachite is an ore copper containing copper 2 carbonate and several other compounds that are insoluble in water. You're supplied with several pieces of malachite. These chemicals and items apparatus describe how you use the chemicals and the apparatus to obtain a sample of copper from malachite. And this obviously is targeting experimental skills, and the students need to create a logical series of answers, and they have to be in order to be able to show how to perform the experiments. They need to have them written down in such a way that another person looking at it could follow the order that they're written and actually do the experiment. And it doesn't matter if they use bullet points, as long as the bullet points are in the correct order. Yeah, so here they would obviously start off by taking the lump of malachite and using the pestle and mortar to grind it up to make a powder out of it. Then they would add that powder to dilute sulfuric acid. Okay, and then that would give, then they would have to filter off the insoluble compounds using the filter funnel and paper. And then that would leave them with a solution of copper sulfate to which they could add the magnesium powder in excess to display, just add the magnesium powder to displace the copper. And then, of course, they can filter off the copper and leave it to dry. And that would be the 6 marks there. Okay, there's a typical calculation question. They're given an equation, and there are 2 types of calculation given here. show that the maximum possible mass of the crystals that can be obtained is 30 grams. I like that type of question because they have to show their working. Whereas in the second experiment, they don't necessarily have to show their working. And the off-qual regulations for UK examinations, which we follow in international examinations, is that a correct answer to a calculation without any working must score full marks. So they don't have to actually show their working in part 2. They could just do it on the calculator and write down a correct answer. And of course, if they give an incorrect answer with no working, they score 0. So it is in their advantage to them to actually show working. But in number 1, they have to show the working because they can't just say, I did the calculation on my calculator and it's come to about 30 grams. Give me 3 marks, please. They won't get it, obviously. Okay. Right, the next one, here's a little activity for you. Don't write anything in the chat box. There are over 65 of you in the room at the moment, and obviously we can't look at 65 sets of answers. So if you've got a piece of paper and a pen, you can write them down. If not, keep them in your head. Okay, what are the 2 essential points to include when answering the following question? Yeah, I'm not asking you to answer the question, but what are the 2 essential points? State the effect of this change on the yield of hydrogen iodide and justify your answer. Okay, so I'll leave you with a little while to gather your thoughts on that one, and then I'll move on to the next slide and show you what I think are the 2 essential points that need to be made here. Okay, hopefully you've had enough time to gather your thoughts there. And for this particular reaction, it is sufficient to say a decrease in temperature increases the yield, and that will score the first of the 2 marks because the forward reaction is exothermic. And that is it. That's all they need to say to score both marks. Notice that there is no reference here to the reaction trying to put back the heat that has been lost because you decrease the temperature, i.e. using Le Chatelier's principle. Le Chatelier's principle is not needed and actually should not be used. And the reason it shouldn't be used is because they won't get any marks for it. Any references to Le Chatelier's principle in these answers will be totally ignored. There will be no credit given to it whatsoever. I did talk yesterday about the fact that I'm a firm believer that the use of Le Chatelier's and the teaching of Le Chatelier's principle leads to an incredible amount of misconceptions. And I have written a topic guide on chemical equilibrium, which is available on the Pearson website. If you go to Pearson qualifications and then click on International GCSEs, and then click on C, and then click on chemistry, and then go to the linear qualification, and then go to teaching and learning materials within that, then you will see a topic guide labeled chemical equilibrium, which I wrote to support the teaching of this topic for this qualification. And in it, I give my explanation as to why I think Le Chatelier's principle causes more confusion than it does help, and an alternative of how to go about teaching it. I'm not telling you how to teach it because I don't know your students. I'm not saying that you don't use Le Chatelier's principle. All I'm saying is there are alternatives and no marks will be given for the use of Le Chatelier's principle in answers in exam questions. So I'll leave it up to you as to how you go about teaching this particular topic. You know your students, I don't. Okay, so enough about that. So let's have a look at activity 2. Again, don't add things into the chat box, please. Just try to gather your thoughts. What are the 5 essential points to include in answer to the following question? Describe how a pure dry sample of hydrated copper 2 sulfate crystals can be obtained from a dilute solution of copper 2 sulfate. This was a part question that followed on a description of making the copper 2 sulfate solution in the first place. And the method of making it was to add an excess of copper 2 oxide, which contains both soluble and insoluble impurities, to dilute sulfuric acid, and then obviously filtering off the excess copper 2 oxide to give you a dilute aqueous solution copper 2 sulfate. So starting from that point, what are the 5 essential points you need to put down to answer that question? And again, I'll give you a minute to have a look at that while I look at the questions in the chat box. I dealt with paper 1 and paper 2. This is a question in the chat box. What are paper 1 and paper 2? I dealt with that yesterday. So there's a lot of explanation that's required there. So the best thing to do is to go to the website and look at what paper 1 and paper 2 are, and both linear and modular. Can you please explain about the previous question about calculation? Can you explain again the calculation question? I think the only thing I need to say is that students should show their working, and if they don't but get a wrong answer, they get no marks. But if they don't show working and get the correct answer, they will get full marks. I hope that helps. Now, you may be wondering why I've asked you twice about thinking about essential points before you actually start writing down an answer. And there's a very good reason for this, because I always try to encourage my students, whenever they get a question that's worth more than 1 mark, particularly if it's worth 3, 4, 5, or 6 marks, before they start writing, get clear in their heads what essential points are that they need to include, so they don't go off on a tangent and start writing down information that is either incorrect or totally irrelevant, so that they can stick to the relevant information. And here, I think the relevant information is as follows. So 1, heat or boil the filtrate. 2, until crystals form in a cooled sample, or until crystals start to form. Leave the solution to cool so that more crystals can form. Filter to remove those crystals, and then dry the crystals on filter paper. You could, of course, have alternative methods of drying, like putting it into a desiccator. Better not to say put it into an oven, because, of course, put it into an oven, the oven could be at a temperature so high that it would dehydrate the crystals and you wouldn't finish up with hydrated crystals. So it's better to avoid the use of an oven in this particular situation. Okay, a couple of questions have come into the chat box. Could you send the presentation? There's no need for me to send the presentation because it's in the resource material in the downloads that are available to you. Okay, there's a PDF version of it. Okay, Edexcel textbook, very minimal. The calculation about kinetic energy. Okay, there's nothing, unfortunately, I can do about that. But thank you for letting me know. On then, I did say that the next thing that we need to look at are these assessment objectives. What are they, and why are they actually used in examination and paper writing. Why do we have them, first of all? Well, as I hope to prove to you as I explain more about the assessment objectives, they help make exams fairer year on year. I know very well, as an experienced exam paper writer for Pearson, that it's impossible to make a write an exam paper 1 year and then the next year that's absolutely identical in terms of degree of difficulty and demand. It's impossible to do that. We can get them very close in terms of demand and difficulty, but we can't get them absolutely identical. And that's one of the reasons why the grade boundaries change from 1 year to the next. But using assessment objectives will actually help us to get exam papers very similar in terms of degree and demand. And I hope I'll be able to explain how that is achieved in the following slides. It also provides a structure for the exam paper writers, and I think you will see what that structure is in oncoming slides. And it makes sure that the exam's about skills and not just about knowledge. And again, I think that will become clear how we achieve that. And it can provide the students with some reassurance about the types of questions they will be asked. It also provides you with some reassurance as well. Okay, a couple more questions come up in the chat book. Can it be said heat the solution to become saturated? Yes. Should the student write about use the distilled water to rinse it? Not necessarily, but it won't do any harm if they did, as long as it's a very small amount of cold distilled water. It would have to be cold distilled water. Okay, hope that answers those two questions. Okay, so here are the three assessment objectives, and they're labelled Assessment Objective 1, 2, and 3, AO1, AO2, AO3. And AO1 is about knowledge and understanding in chemistry, but very straightforward understanding, nothing of any great degree of difficulty, okay? Linking really to things that are in the specification itself. So they could be asked to draw a dot and cross diagram for water. That is in the specification. It needs a little bit of understanding of chemistry, but that would call into AO1. If it was to draw a dot and cross diagram for hydrogen sulfide, then that would fall into AO2, because AO2 is about the application of knowledge and understanding, and it's also about analysis and evaluation in chemistry. Hydrogen sulfide is not on the specification, therefore they would have to use their knowledge of the dot and cross diagram for water, and the knowledge that sulfur is in the same group of the periodic table as oxygen, and therefore the dot and cross diagram should be the same. So it's an application of knowledge. So that falls into AO2. Now you can see straight away, of course, that AO2 is now testing skills, not testing recall. So one of the points I made on the previous page, which is to make sure that the papers are about skills and not just about knowledge, is fulfilled. And that also is fulfilled with AO3, because AO3 is all about experimental skills. It's about analysis and evaluation of data and methods in chemistry, and they can be asked questions, as I will point out later, on all sorts of things, experiments that they've actually not seen or performed or heard about before. And they've got to apply the knowledge and the skills they've developed during the practicals that they have done throughout the course to these unfamiliar situations. So once again, it will be partly about skills. There will be some recall there because there are 12 core practicals listed in the specification in italics, and the examiners can ask questions about knowledge of any one of those 12 core practicals, as I mentioned yesterday. So looking at the types of questions that could well be set here, AO1 will be questions requiring students to recall and use the information you've taught them. The recall statements are the ones that are listed in the specification, start off with students should know that. So any specification statement that says no is a recall statement. And yesterday I advised the students just simply to learn those statements and to use information that you've actually taught them in very, very simple understanding. AO2 are questions requiring students to apply what you've taught them, or to use skills, or to analyse and make judgments. And AO3 will be questions on practical work and associated practical skills, such as planning, drawing graphs, analysing data, and evaluating methods. Now, later on during the presentation, we'll be looking at some questions that are targeted at AO2 and targeted AO3, and I think that will give you a better understanding of the types of questions that are set in these particular two contexts. Okay, now how do we make the exams fairer year on year, and how does it provide a structure for the exam paper writers? Well, when they are constructing their papers, they must make sure that the questions that target AO1 do not go very much above or below 40%. They've got to be somewhere around about 40%. If they're between 38% and 42%, that's okay. AO2, again, has got to be around about 40%, and AO3 has got to be 20%. So that means that every single examination paper that is written has got roughly the same makeup of AO1, AO2, and AO3 questions. So the exam papers can therefore be made fairer from one year to the next, and it will also give both you and your students some confidence that the makeup of the papers from one year to the next will be very, very similar, because they're going to be similar percentages of AO1, AO2, and AO3 questions in them. Okay, so a couple of questions just come up into the chat box. I'll have a look at them. Can you download? Okay, right. Okay, they don't apply to me, so I'll move on. So paper 1 and paper 2 both have exactly the same balance of AO1 and AO2 and AO3. Compared to the previous specification, the new specification has less AO1 and more AO2. So now we are testing a little bit more of skills than we used to in the previous specification, which personally I think is a good thing. So let's have a look at some typical AO1 questions. They can be simple recall, or they can be based on understanding and not just knowledge, but as I said, basic understanding. AO2 questions can involve simple ideas being applied to unfamiliar scenarios. I gave you one example of hydrogen sulfide, or they can involve more complex scenarios involving data analysis or evaluation of data. And AO3 questions are those based on practical experiences, and not just the core practicals, but any practical work. I know that when I set some questions on AO3, I was hoping that no student sitting the exam, no candidate sitting the exam, had seen or heard of or had any familiarity with this particular experiment, because I was testing their ability to be able to apply what they had learned to an unfamiliar situation. And I'm sure that the exam paper writers who are in existence now will be thinking along the same lines themselves as well at certain times. There's a question which is one that I wrote. I remember very much writing this one. Okay, that targets AO3. Name the acid and the alkali that can be used to make sodium chloride. And then a teacher drops a bottle containing sodium chloride. The bottle breaks when it hits the floor. The teacher sweeps up the mixture of sodium chloride in glass. Describe how the teacher can obtain a pure, dry sample of sodium chloride from the mixture. Now, remember that this is one of my questions, because when I originally wrote it, I had it as a student doing this. And then, for health and safety reasons, I was told that we can't have students sweeping up broken glass. So I had to change it to a teacher. Here, we're expecting the students to apply their knowledge to solve this particular problem and come up with a plan of an experiment. They should know, for example, that glass doesn't dissolve in water, but sodium chloride does. So they should then be able to say, right, let's put the mixture into a beaker and add water to it and stir it up. The sodium chloride will dissolve, so let's filter off the glass and then leave the solution of sodium chloride to evaporate to dryness so that you get a dry sample of sodium chloride, well, a wet sample, and then you dry it on filter paper. Interestingly, here we can't follow the crystallization method because the solubility of sodium chloride in water is virtually the same in both cold water and hot water. So there's absolutely no point in heating this solution to make a saturated solution and then leave it to cool and crystallize. You won't get very much sodium chloride crystallizing out, if any. So the students need to be aware that the solubility of sodium chloride is almost identical in both cold and hot water. So they have to leave it to evaporate to dryness. Okay, right, now then, unlike yesterday, I've now got quite a bit of work for you to do. And again, I'm going to ask you not to put any answers down on the in the chat box, but I'm going to give you time, if you haven't already got it, to get a piece of paper and a pen, because I think you may want to put down the answers to these, because you may want to use these questions with your students at a later date and get them to do some marking, because it might give them a little bit of better insight into how the marking is done and therefore influence how they answer their questions themselves. So what we're going to do is, this is all about assigning AOs, so you may want to write down the answers to these, and you may want to use these with your students, sorry, to get the assessment objectives. There's the first one. Remember that AO1 is about application of knowledge and basic understanding. AO, is about recall of knowledge and basic understanding. AO2 is about application, and AO3 is about experimental skills. So the question you've got to keep asking yourself all the time is the information required here on the specification? So do they need to know, is it on the specification what the color of the flame test for lithium ions is? And those of you who know the specification will know that that is on the specification. So it is AO1. There's the second one. I'm not sure what you mean by science single award, no practical. There will be questions on the practical in the single award, I'm sure, but there's obviously no practical work that they have to do and be tested on. Okay, don't worry about putting down answers into the chat box. As I said, there's now 73 of you in the room. We can't monitor all of those. Now here, the students do need to know that the formula of the ammonium ion is NH4+. They do need to know that the formula of the carbonate ion is CO32-. They are on the specification. But then obviously they need to take that knowledge and apply it in order to work out a formula. So that is AO2. Okay. Right, there are three parts to this question, so there are three separate assessment objectives, which could be the same or they could be different. I'll leave you to have a think about each one. Dotty 1, Dotty 2, and Dotty 3. Oh gosh, there's a huge number come up to the chat box. Calculation questions, how many significant figures or decimal places should the answers be written to? Well, if there's no requirement to give your answer to a specific number significant figures, then they can give their answer to any number of significant figures. If they're asked to give their answer to an appropriate number of significant figures, then they should give the answer to the number of significant figures that is the lowest in the data supplied. So if you've got 4 bits of data, all at 4 sig figs, and one of them at 3 sig figs, your final answer should be to 3 sig figs. And if the question says, give your answer to 3 significant figures, then obviously it must be to 3 significant figures. Okay. Right, here are my answers to these. The first one is AO1 because that is direct recall from the specification. The second one is also AO1 because it is basic knowledge. It's no real difficulty in knowing that aluminium is more reactive than iron. So that is also AO1. And explain why this is a redox reaction is also AO1 because I would consider that to be basic knowledge, that you have got the iron 3 oxide losing oxygen and the aluminium gaining oxygen, so you've got both reduction and oxidation taking place. I would consider all of those AO1. Okay, there's the next one. It's a calculation. The top one is explain why the student needs to clean the platinum wire. The bottom one is a calculation. Cleaning the platinum wire is clearly AO3 because it's an experimental technique. All calculations are AO2. I say all, but you could perhaps argue that calculating a relative mass of a very simple molecule, like a simple substance, like say sodium fluoride or water, where there's only a few atoms present within the formula, could be AO1 because it's a very, very simple, straightforward calculation. But in the main, calculations are AO2. Right, now there's an interesting one. Have a think about that one. Question you've got to ask yourself is, should the students know about the test for ammonium ions and carbonate ions? In other words, are those tests on the specification? And the answer is yes. So it's AO1. It's not AO3, despite the fact, of course, it's something that you would have to do as a practical to prove it. As an examination question, you're testing recall of knowledge from the specification. So it's actually AO1. Okay, there's another one. Give 2 observations made when sodium reacts with water. That's observations of an experiment, and therefore that is classified as AO3. And stating the color that's formed would also be AO3. So those 2 are actually AO3. Explanation of the color, however, would be AO1 because that's basic understanding of a solution, an alkaline solution, changing the color of phenolphthalein, which is on the specification. Okay, so I hope that helps you appreciate the types of questions that are targeting AO1, AO2, and AO3, okay? The other important thing about the questions that are set is that they are no longer questions, they're actually commands. The only time that the exam paper writers are allowed to use a question is in a multiple choice. At all other times, they must use command words. So they're all in the specification in a particular appendix. I can't remember the appendix number, but the appendices are all towards the end of the document. So if you download the specification from the website, in the International GCSE Chemistry section of the website, download the specification, you can get a list of those command words. And one of the things I always said to my students was, they can access this as well, download that, print it off, and put it in your folder. And every single time you go to a question, look at the command word and look at your list, find that command word in your list and see what that command word states that you have to do to answer this question. The command words actually do represent a range of skills. So for example, you've got simple recall, like give, name, state, label, a diagram, that sort of thing. Okay, or use knowledge, like describe, or give reasons, like explain, and provide more details and analysis, like evaluate or justify, or show particular skills, like calculate or plot, One of the reasons I think it's very useful for the students to look at this, and for you actually perhaps also to talk through them, with them, some of these command words, is that there's very subtle differences between some that in everyday language would actually probably mean the same thing, like deduce and determine. Now, if you go and look at the command words that are listed in the specification, you see there is a difference between deduce and determine as far as the exam is concerned, because in determine, they have to have some quantitative explanation, i.e. a calculation of some description in order to get all the marks. They don't need that for deduce. The other thing that's important here is if you go back and look at the previous specification and look at some of the questions from the previous specification, which you can see on Exam Wizard, you will see that on some occasions there are two command words used in the same sentence. The exam paper writers now are not allowed to use two command words in the same sentence. If they want to use two command words in the question, they have to write two separate sentences. So that means that the word explain could actually mean state and explain. Let me give you an example. Explain how the rate of the reaction changes between magnesium and hydrochloric acid when the concentration of the hydrochloric acid is increased. Now, they're not told how it changes. Therefore, the first thing they must do is write down it will increase and then offer their explanation. So they actually have to state and then explain. So that single command word actually covers two commands. So in the old days, you could say state and explain, but now you can't. Explain could mean just simply explain. So explain why the rate of the reaction increases as the concentration of hydrochloric acid increases. Their coded increases. All they have to do this time is explain. So there can be differences. Is there a link between command words and AOs? Yeah, I think so. But before I go on to that, I can see that there's quite a number of questions coming up here. Okay. Are they going to have a table at the end of the experiment, or will they memorize them, like in paper 6 Cambridge, a table at the end of experiments? No, I'm not familiar with paper 6 Cambridge, but I've never seen a table at the end of experiments. Or will they memorize them? Yeah, they have to memorize them. Presumably because they perform them, they should have a knowledge of them. That is the way in which we think as examiners. Okay, right, moving on. Assigning command words to AOs, I think there is some degree of link. So for example, add, label, describe, explain very simple things, give, state, name, or give a reason for very simple explanations will fall into AO1, whereas calculate, identify, deduce, determine, predict, suggest, or write a chemical equation would be AO2. AO3 could have things like deduce, design, draw, estimate, evaluate, or plot. So yes, there is some degree of link between command words and the assessment objectives. So the command words will be giving you possibly some indication of what the assessment objective the question is targeting. Okay, now here's where we come on to you to do a little bit of work of your own. We're going to look at some AO2 questions, some mark schemes, and I'm going to give you the opportunity to mark some student work taken from last year's question papers, and not last year's, this year's, the May June 2024 series. Okay, now you may be wondering, why am I not going to look at AO1? Well, there's a very good reason. It's all about knowledge and basic understanding. This is one that the teachers really can't influence much. They either go away and learn what you teach them, or they don't. There's an old saying, you can take a horse to water, but you can't make them drink. So you can tell them what they need to learn and need to memorize, and if they don't bother doing so, there's nothing you can do about that. So that's the reason I've decided not to look at AO1 today. But however, one of the reasons why I wanted to go through assessment objectives and show you some type of question that are targeting AO1 is I think students should still recognize what questions are targeting AO1 so they don't spend time going beyond the requirements for answering AO1 question. It's not supposed to be a difficult question. It's supposed to be either just recall or offering explanations of very, very simple, straightforward chemistry. So they don't need to write down full, detailed and long explanations. So that's why I think it's useful for them to be aware that there are questions targeting AO1. And the more work you can do to make them aware of this, the better. So what is AO2? Well, as I said, it's application of knowledge to unfamiliar situations. And here's a question that I set a number of years ago, where you've got some N2O4 and NO2. You've got it in a sealed gas syringe. You're allowed to form an equilibrium mixture. I tell you that that equilibrium mixture is brown. So there must be a higher concentration of NO2 than N2O4. Otherwise, it wouldn't be significantly brown. The pressure in the gas syringe is increased by pushing in the piston. The mixture is then allowed to reach a new equilibrium at the same temperature. Explain why the equilibrium mixture contains less NO2 than the original one. And remember that you should not be making any reference to Le Chatelier's principle. In this question, part A gave them the equation, and it had N2O4 reversible arrow, 2N2O4 reversible arrows NO2. Sorry, I'll start again. N2O4 reversible arrows 2NO2. So what the students should now be saying is, right, if you increase the pressure, then the reaction will move to the side where there are fewer molecules of gas. So what you do is it's increased, so they move where there are fewer molecules of gas, which will be the N2O4 side. They're also told in part A that N2O4 is colorless and NO2 is brown. So they can then say that the equilibrium position is shifting to the left because there are fewer moles of gas on the left-hand side. And that's all they need to say. No reference to Le Chatelier's principle at all. Okay, so that is an application of knowledge to an unfamiliar situation. There's a calculation. And again, I like this type of calculation because they have to show their working. They can't simply say, I did the calculation on my calculator and it showed a 1:1:3 ratio. They must show their working. So that's an AO2. Chemical equations are AO2, so that one complete combustion of ethanol in air. Okay, an unfamiliar dot and cross diagram, because of course we've given them the displayed formula. They should know that that line represents a shared pair of electrons, and so they should be able to put down a dot and a cross for each line between the carbon and the fluorines and the carbon and the bromine, and then of course add the non-bonding electrons on all three fluorines and all three bromines. And because that molecule is not on the specification, they have to apply their knowledge to answer the question. So that's AO2 as well. Okay, so here we go. It's now your turn to do a little bit of work. Use the mark scheme shown on the screen to mark the student responses on slides 39 to 52, so the next 13 or 14 slides. We'll go through each question one at a time. Here's the first question I want you to deal with. Nitrogen dioxide produced in car engines reacts with water vapor and oxygen in the atmosphere to form nitric acid. Write a chemical equation for this reaction. So there's the first equation there. 4NO2 plus 2H2O plus O2 gives 4NO3. That's the one that we expect them to write. The first mark is for all of the formulae being correct. The second mark is for balancing. In the notes column, you can see that we can allow multiples and fractions, so you can double it up, triple it up, or halve it. Ignore state symbols, even if incorrect, because state symbols have not been asked for. But notice, very importantly, that they can only obtain the second mark if they get the first mark correct. M2 dependent on M1 means they have to get all four formulae correct to get the balancing mark. Okay, now just before we move on, there's a question cropped up. Table of cations and anions tests. No, they need to memorize them. I know what you mean. Yep, they need to memorize the cation and anions tests. Okay, so here we go with the very first one. Now, if you haven't got a piece of paper and a pen, just grab hold of one and write down the answers to all of these, because all of these questions are on the PDF version of the slides that I've supplied for you. And as I said, you may want to use some of these with your students and get them to do some marking. That would be entirely up to you, of course. Okay, there's the first one. Okay, I'm fairly confident that that scores 2 marks because you can allow multiples. They've multiplied up by 1.5. So 2 marks. Next one. Marks. Okay. Ignore state symbols, even if incorrect. They've given the state symbol of G for H2O. Okay, so that is in fact incorrect, but we can ignore state symbols, look at the notes column. So ignore state symbols, even if incorrect. So that scores 2 marks. Okay, student 3. I've just been asked about what ignore means. Ignore means literally that, ignore it. So if they put in the state symbols, ignore them. Okay, you don't penalize. You only penalize, reject, not ignore. Okay, this candidate scores 0 in my book. Why? I know the equation is correctly balanced, but the second mark is dependent on them getting all the formulae correct, and they haven't got the formulae correct for oxygen. So it scores 0. Correctly balanced, but M2 dependent on M1. That's a very good one to show your students. It's very common to write down the formula for oxygen as O. Okay, last one. Here's an example where they have divided it by 2. They're working in halves, therefore scores 2 marks. Allow fractions. When I did my chemistry exam, it was at O levels in those days, GCSEs didn't exist, you would not have been allowed that mark. And I remember my chemistry teacher saying once, when I put down half O2 in the equation, "What are you doing, you stupid boy? You cannot have half a molecule. You can only have whole molecules." Now, of course, those numbers in front of the formulae do not refer to numbers of molecules, they refer to numbers of moles. And you can have half a mole of oxygen molecules. So that's a perfectly acceptable equation. Okay. Right, what I'm going to do there, we've come to nearly halfway. I'm just going to have a 3-minute break up till 10 o'clock. Okay, have a look at that question and have a look at the mark scheme, and I'll bring up the questions, the student answers in 3 minutes time at 10 o'clock. It's 9:57 at the moment. Okay, so let's just have a 3-minute break. Just have a comfort break if we need it. Okay, everyone, it's 10 o'clock. We're back online. I'll just go through the questions that have come into the chat box. Hi, Cliff. Can you give some detail about explain stroke describe questions? Are the students allowed to answer in bullet points, or use headings, or do they have to answer in paragraph form? They can answer in bullet points, but the bullet points should be in the correct order. They so that if they put the bullet points together to make a single paragraph, it would make a logical sense. Okay, so yes, they can answer in bullet points. Right, sometimes we realize that for international students whose English is a second language may face a problem in communicating their answers. Their explanation may not be adequate, or the English may not make a lot of sense. Is this catered for when marking? Moreover, we find that a student probably got 140 out of 300 marks and got a U grade. That means the student did nothing. Is the way of standardizing these grades to avoid disadvantaging these kids? Kindly elaborate. Okay, I can answer the first one, but I can't answer the second. The first one is yes. We do make allowances So, for example, we're not insistent on 100% accurate spelling unless it changes the chemistry. For example, if the answer to a question was ethene is produced and they wrote down ethane, then obviously it would be marked wrong because they're changing the chemistry. However, if the question said, what is the observation? And the observation was effervescence, and they don't spell effervescence correctly, but it's pretty obviously effervescence, then we allow that as an answer. We don't penalize. And whenever we're reading the English, we look at it and they say, although the English may not be ideal, it may not be perfect, have they explained themselves correctly with regard to the chemistry? And that is the most important point that we look at. We always look to try to give credit for the chemistry wherever it is possible. In other words, our objective is always to be positive in our marking, not negative in our marking. Okay, I hope that helps. Okay, here we go. Describe a test for chlorine. And the test that we expect them to use is to use litmus paper. Now, we would, of course, prefer them to use damp or moist litmus paper, preferably blue litmus paper. But you'll notice that use damp blue is in brackets. And that means it's not essential to be in our answer. It means that's what we'd like to see, but it's not, we're not insisting on it. So however, we are insisting on litmus paper. And notice in the notes column, we will allow universal indicator paper. And then for the second mark, the litmus paper is bleached or turns white. Ignore gas or solution here. I don't know why it appears in the answer column. It should be just in the notes column, which is where it is. Okay. Except blue litmus paper turns red and is then bleached because, of course, chlorine solution is slightly acidic because it forms a mixture of chloric 1 acid and hydrochloric acid. Allow for the first mark, bromide solution turns brown. Well, that won't crop up in any of the shoot answers that I'm about to show you, so we don't need that. Reject iodide solution. Notice that M2 is dependent on M1, and red litmus paper turns blue, then bleaches or turns white, scores M1 only. Okay, so here we go. There's your first student answer. So damp red litmus paper scores 1 mark, will bleach scores the second mark, so that candidate gets 2 marks in totals. Okay. Next one. If you look at the bottom right-hand corner of the notes column, right at the bottom there, red litmus paper turns blue, then bleaches, scores M1 only. So 1 mark. Student 3. Now, here is where we've got an example of a student who's crossed out their answer, but has not replaced it with any other answer. And the rules that need to be employed in marking here is that any work crossed out but not replaced must be looked at, and if there's credit due, if marks can be awarded, then they should be awarded. So this candidate scores M1 for damp litmus paper and M2 for bleaches, and therefore gets 2 marks. Now, this is a useful one to show your students, because if they do cross out work and don't replace it, it will be looked at, and they need to be aware of that. However, if they do cross out work and then replace it, what's been crossed out will then be ignored. It won't be looked at. And what will be marked is what they've written down as an alternative. Okay? But if it's crossed out and not replaced, it will be marked. So that candidate scores 2 marks. Next one, student 4. Well, the notes column says that we can allow universal indicator, so they score M1, and then down the bottom there, they say it's bleached, so that gets M2, so 2 marks. Okay, here's the third question. Sample of element Z contains 3 isotopes. The table shows the number of particles in the nucleus of each isotope. Use the information in the table to calculate the relative atomic mass of element Z. Give your answer to 1 decimal place. So this is where the final answer has got to be to 1 decimal place. So let's have a look at how this was marked last May. The first mark was for showing somewhere in the calculation that they have used 24, 25, and 26. The next mark was for showing somewhere in the calculation, either showing that they multiplied 79.0 by 24, and 10.0 by 25, and 11.0 by 26. So they can either show that, or they could write down 2,432. They don't have to show the working. Okay? Then the next thing they have to do is to divide that by 100. So divide 2,432 by 100, or just simply write down 24.32. And that scores the third mark. And the fourth mark is for putting their final answer to 1 decimal place, 24.3. Okay, M2 subsumes M1. If they've shown, because you can see that they've used 24, 25, and 26. So if they've just written down that bit of the calculation, or just written down 2432, then they get the first 2 marks. If they write down 2432 divided by 100 equals 24.32, they've got 3 marks, because they must have used 24, 25, and 26 to get 2,432. Okay. Notice also in the note columns, allow error carried forward. That's what ECF means, if incorrect mass number is used. So if you use the incorrect mass numbers, I think it's 12, 13, and 14 that they use, they come up with an answer of 12.3. So if they've got an answer of 12.3, it scores 3 marks as long as they've shown some working. 24.3 without working scores 4, because the Ofquat regulations are quite simply that correct final answer with no working scores all marks. 24.32 without working scores 3. M4 scores only if the numbers from the table are used. So in other words, they can't get an error carried forward for giving their final answer to one decimal place unless they've used some of the numbers from the table. Okay, I hope that's all clear. Let's have a look at the first calculation. For those of you who are pretty quick on looking through that calculation will have spotted that the final answer is correct, so it must be 4 marks. But if you want to see where the 4 marks are actually allocated, the first one's allocated there, the second one's allocated there, the third one's allocated there, and the fourth one is allocated there. So that candidate gets 4 marks. One of the things we tell our examiners is look at the final answer before you look at the working. And if the final answer is correct, then it's almost certain, particularly in this type of calculation, that they've done the calculation correctly. I can't see any other way in which they could do the calculation and get 24.3 other than do it correctly. So if the 24.3 is there as a final answer, full marks, move on. Don't bother looking at the working. Okay, I can't see how they could get cancelling errors in this particular calculation. I don't think I suppose it's possible. I'll be honest with you, I have been marking did mark exam papers from 1984 right the way through into the until 2017. So 33 years of marking exam papers every single year, sometimes twice a year. And I've never, ever seen compensating errors leading to a correct answer in a calculation in all my time. And I've looked at thousands and thousands and thousands of exam scripts over those 33 years. I suppose it can happen. It's just never happened to me. Okay, right, there's the second one. If you've looked closely at the notes column, you will see that 12.3 scores 3 with working. There is some working shown. They've used 12, 13, and 14, which are the incorrect mass numbers, and they've come up with 12.3, so they score 3 marks. 12.3 scores 3 with working. Third point in the notes column. Okay, so once again, our examiners will be clued into that. They see 12.3, they see some working, 3 marks given, away they go. Okay, next one. There's no working, but the fourth line in the notes column says 24.32 without working, scores 3. 3 marks. Student 4. No marks. Incorrect answer with no working, scores 4. If they'd shown working and they'd got down to 24.32 and then given their final answer as 24, they'd have scored 3. But because there's no working, can't give any marks. Right, before I move on, there's a number of questions in the chat box. I'll see if I can go down through any of these. Can you please explain the mark scheme changes every series according to the student's answers? No one can I can't explain that. And at the end of the presentation, I will give you the contact details for the subject officer at Pearson's. Send that question to him, please, and he will find an answer for you for that, okay? I can make no comment on answers in mark schemes appearing differently from one year to the next. You are getting electronic certificates. Okay, the rest of the questions don't apply to me. So On we go. Okay, so how can we go about preparing students for AO2? Teaching approaches. Is it better to present facts or to teach principles, and why? Well, since AO2 is all about application of knowledge, then obviously facts on their own are not enough. So you must teach principles as well as facts. And of course, there's an old saying, you cannot think in a vacuum. So students need to pack their heads with facts and then learn how to use those facts to apply them to answer questions involving principles. So teaching principles is very important to preparing students to answer AO2 questions. Questioning styles. And now obviously you ask questions during the course of your lessons. Is it better to ask closed or open questions, and why? Well, closed questions are those requiring a single answer, which will always be simply recall. Recall is AO1, not AO2. Open questions are where they have to think through an answer and apply their knowledge to solve the question, to answer the question that you've asked. So obviously open questions are much better. I'm just trying to think of something from GCSE. You can't, but I can think of something from A-level. In A-level, you could ask the question, what is the name of the catalyst used in the Haber process? Answer, iron. Okay, that's a closed question. Open question, how does the catalyst work? How does a heterogeneous catalyst work in a gas phase reaction? So there they have to think about the whole mechanism of the molecules absorbing onto the catalyst, weakening the bonds between the molecules, lowering the activation energy, allowing the molecules to react, and then the reactant molecules desorbing, leaving room for other reactant molecules to adsorb. So it's an open question. Assessment activities, you obviously test them, and you might test them during the lesson by giving them a worksheet or you might do a simple test, a verbal test, or a test where you project it up onto the board. Is it better to set formative or summative assessments, and why? Summative assessments are simply where the only thing you're interested in is their final score, because what you're doing is you're putting them into rank order and giving them a position within a particular class or year group. This is what examinations do. They simply put candidates into rank order and say a certain percentage will get grade 9, another percentage will get grade 8, and then so on, so on, so on, right down to grade 1 and unclassified. So that's what summative assessment is. Now you've got to ask yourself, is it useful for a student to know that they are first in the class out of 20, or 10th in the class out of 20, or 20th in the class out of 20? What does that tell them about what they need to do to improve their performance? Being told they're 20th, or they are told, all they know is I must do better. But how can I do better? Formative assessments are where you actually use the assessments to give them feedback, to give them some indication about what they have answered well and what they've answered not so well, and what they could do to improve their performance in a future question. So obviously formative assessments are much better than summative assessments. And exam preparation, what else could you do to prepare your students to answer AO2 questions? Well, one of the things obviously you can do is to give them plenty of practice in answering AO2 questions. You've got some mechanism of identifying them from past paper questions yourself from the work that we've done today, but also you could use Exam Wizard and you could actually target AO2 questions. If you go into Exam Wizard and go through the user guide, you will find out how you can actually select out AO2 questions from a drop-down box and create a test on AO2 questions on a particular topic, if you like, and give those to your students and say, here are a whole series of AO2 questions. get some practice on answering them. So that's one thing, and I'm sure there are lots of other things that you can come up with as well. So there's some things for you to think about as you go away. Question styles. So this is something for you to think about, not now, because of course there are over 70 of you in the room, so we can't obviously get feedback from all of you here. Okay. Think about one of the topics that you teach, which often has AO2 questions in exams. Again, look at past papers and pick out topics that commonly have AO2. And then from that, think about the sorts of questions that you ask in class when you teach this topic, and how do these questions help your students to prepare for AO2, okay? Right, there's a few questions come into the chat box here, okay? Sir, can I suggest, is it possible that you can give more weight of scores in practical experiment than structured questions paper? For me, practical experiment is more authentic. I've already pointed out the rules and regulations for the number of marks that can be allocated for AO3, and it is no more than 20%. So that is the maximum that the exam paper writers are allowed to give for AO3 in the exam papers. So the answer is no, you can't give more weights of scores. Okay, and yes, I agree with you, practical experiment is more authentic, but there are rules for the exam papers, for the exam writers, exam paper writers, no more than 20% on AO3. Okay. Okay, another thing for you to think about is homework activities. Why do you set homework? I know when I first started teaching, the reason I set homework is because I was told to. You must set homework. So I thought, oh, I'll set some homework. I never gave an awful lot of thought as to why I actually set it. As I got more and more experienced in teaching, I suddenly came to realize that perhaps the homework I should be setting should have more meaning to it than just setting homework. It's possible that the homework I did set did have meaning, but I didn't think about what that did. So I didn't really give a lot of thought into what sort of questions or problems I set for homework. I just set some homework because I was told I had to. So as I got more and more experienced in teaching, and I did find that I did actually teach for 38 years. I retired just over in 2011, so just over 13 years ago. As I did more and more teaching, I gave more and more thought to the sorts of questions I set for homework. Okay. What do you expect your students to gain from the questions that you set? So I even went in to think about that. I thought, what sort of questions probably do I set? What do I expect my students to gain from this? Am I setting them questions that's actually going to help them to improve their knowledge, understanding, and enable them to be able to apply their knowledge and understanding? Am I giving them practice in these areas, which I think is so important? What will they gain that help them to answer AO2 questions? So there's some things for you to think about. Okay, now let's have a look at AO3 questions in mark schemes. And I think I'm probably going to have to go through these a little bit more quickly than I did go through the other ones, okay? AO3, of course, is all about assessing practical skills and understanding gained by students as they undertake practical work. They may require recall of practical techniques, i.e. those that are in the core practicals, and the understanding or application of these techniques to new situations. They may also involve the use of experimental data and the evaluation of experimental results. Okay, so for example, describe how the student could obtain a pure dry sample of crystal hydrated crystals from filtrating stage 6. That was, of course, the question I talked about earlier, okay, where you go through filtering off, you've got the filtering off the excess copper oxide, you get the copper sulfate solution, and then you go through the crystallization process. So that's a recall of the practical technique. That's taken from statement in the linear specification 2.42, Practical. Prepare a sample of pure, dry, hydrated copper-2 sulfate crystals starting from copper-2 oxide. Okay, so that's a direct recall of a practical technique from a practical that's listed in the specification. If, however, the question is all about adding magnesium oxide to sulfuric acid and then trying to get hydrated magnesium sulfate, that would be an application of a practical technique rather than the recall of a practical technique. Subtle difference. Okay, the graph on the next slide shows the results of reacting two different acids, X and Y, with the same mass of magnesium ribbon at the same temperature. Explain how the curves show which acid has the greater concentration of hydrogen ions. Well, there's the graph, and what we expect students to do is to go down one of two routes. Either say that the gradient of curve X is greater than that of Y, and therefore the reaction must be faster, so X must have the higher concentration, or to pick a particular time, say 20 seconds, and say in 20 seconds there's only 6 cubic centimeters of gas given off with Y, but there's 12 given off with X, so the reaction must be faster with X, so X must have the higher concentration. So they have to make use of the graph one way or another, either by using the gradients or taking readings from the graph. They can't just say X has the higher concentration and expect to get full marks. Evaluation of methods. Here's a well-known experiment where, don't bother reading all of this lot, just let me explain it to you. You put the dilute hydrochloric acid into the conical flask, and then you add the magnesium ribbon and put the rubber bung in and collect the gas. Okay, you'd expect 86 cubic centimeters to be given off. Why don't you get that? The results table actually showed that only 84 came off. And of course, it's because some gas is lost. So what you're doing is you are looking at the procedure and working out where there is a procedural error. So you're evaluating the method. The student uses a graduated beaker to measure the volume of dilute hydrochloric acid. Explain why it's not necessary. Well, because the acid's in excess. So why do you need to measure it out precisely? You don't. So a beaker is perfectly okay to measure out the 50. Okay, as long as it's a graduated beaker, you don't need to use any measuring cylinder or burette or anything like that. It's in excess. So no need to use any more better precision apparatus. Okay, here's the result of this particular one. The question was poorly answered by the majority of candidates. Many said that the gas escapes or is lost, but very few went on to say why it escapes. So this was insufficient to get the mark. Some said that magnesium did not fully react, which was not creditworthy as the acid was in excess. So there's no reason why it should stop reacting. In part D, the question was not particularly well answered. Many talked about accurate measurements not being required, but failed to mention that this was because the acid was in excess. As the second marking point would depend on the first answers, as such as these could not be awarded any marks. Notice that on both occasions, this evaluation question, the question was poorly answered, suggesting that more work, as much work as you can do with them on evaluations, as many examples you can give them, the better. Okay, here's an example of use of data. Explain how the results show which alcohol evaporates most easily. They are given times, they're given mean times. Okay, and you can see that the mean time is lowest for methanol, and therefore that must be the alcohol that's evaporating most easily. And because the data is given in terms of times, it's times that's actually required in the answer. Okay, so here's the examiner's report. Most candidates identified that methanol was the alcohol that evaporates most easily, so got your first mark. The question asked for an explanation for this from the results, and the results in the table were values of times. So the required explanation needed to refer to methanol taking the shortest time, and some candidates didn't refer to the time, so they didn't get their mark. Okay, there are certain terminologies that are used in practicals like validity, anomaly, precision, accuracy, and reliability. We don't expect students to be able to state what is meant by each of these, but they should be able to recognize what when these terms mean in a practical context. And that is all explained in that guidance book, which is on the Pearson website in the linear qualification. So International GCSE Chemistry linear specification, linear qualification, under teaching and learning resources, then you will find that document. Have a read through it on use of practical terminology. Now, how do we expect them to be able to use this terminology? Well, here's a couple of examples here. Explain how the cotton wool increases the accuracy of this investigation. Well, of course, it stops the acid spray escaping. A lot of students said it stops the gas escaping, which is rather strange because, of course, the reason why the mass decreases is because the gas is escaping. There's one for validity. State 2 variables the student should use to make sure the results are valid. This is the experiment that linked that data that I showed you earlier about the alcohols evaporating. And of course, they need to make sure that they've got the same surface area of alcohol. So if they're using the same evaporating basin, they need the same volume. And of course, the hot water needs to be at the same temperature. So although they don't have to explain what is meant by validity, they should have an appreciation of what they need to do to get the results to be valid. Okay. Right, so a bit more marking for you to do. Here we go. And here's where I think I'll probably have to go through these a little bit more quickly. We've got 27 minutes left. And I still got some things to do to show you on support. So there's the very first question. Ethanol can be obtained from a solution of cathode ethanol using this apparatus. Describe what happens to the ethanol in apparatus X. And the answer simply is it cools and condenses, or it cools and forms a liquid. Simply it. It cools and condenses. That's all they actually need to say. Right? So there's the first question. How many marks? Have they mentioned it cools? Yes, M1. Have they mentioned it condenses or turns into a liquid? Yes. M2. 2 marks. Okay, nice, straightforward starter. There's student 2. Have a look to see if they've mentioned if it cools. No. Have they mentioned it condenses? Yes. So they get the 2nd mark, but not the 1st. No mention of cooling, so no M1, 1 mark. Okay, next one. Have a look to see if they've mentioned anything about cooling. Then look, mentioned anything about condensing. Have mentioned condenses. They haven't mentioned cooling. So they don't get M1. They do get M2. So they get a 2nd mark. Student 4. Cools down, 1 mark. Condenses, 1 mark. Look at that. There will be 4 lines left of this. This student's got his answer down in 1 mark. Cools down and condenses. 2 marks. Note the concise answer. All that's needed. A good example to show your students about the non-necessity for writing lots of information, putting down lots of information. They can answer that question as simply as cools down, condenses. Okay, that's it. Okay, there's the next question. There's the results of a chromatography experiment. Okay, and you can see the results for both E, F, G, and H. E is made up of 2 components. F hasn't moved, so we've no idea how many components are in it. G has got 1 component, and H has got 2. So the first question says, the chromatography paper is placed in a solvent. Explain why the spots on the baseline are placed above the level in the solvent. Okay, that's because if they are not explained based on a place about the level of the solvent, then if they won't dissolve, the first mark is they won't dissolve or diffuse into the solvent, and then that means the dyes can then travel up the paper. Yep, so they're the 2 marks for part 1. Part 2, explain which 2 felt tip pens contain the same dye. Well, it's obviously E and H because they've got a dye or a spot at the same level. Okay, they've got a spot that's traveled the same distance, or they've got the same RF value. And part 3 is the student thought that both F and G contained only one dye. Explain why the student can be certain about one of these dyes, but it can only be certain about G because F hasn't moved, because it's insoluble. Now, there's something interesting to note in the notes column here, okay? And that is for part 2, M2 is dependent on M1. But it doesn't say in the notes column that M2 is dependent on M1 for part 3. So we have to mark the two marking points independently in part 3. Okay, they have to be marked independently. It's possible that that may not have been what the principal examiner wanted, and I think we'll see that in one of the student answers in a moment. So to have a look at the first one. Okay. So do they mention that the spots don't dissolve? Yes, they do. Do they mention that so the dyes can travel up the paper? Instead, they can move up the paper using the solvent. Yeah, good. So that candidate gets 2 marks. Right, what are the 2 that are the same, E and H? Yep, they've got those. One of the spots is shared by the 2 of them. Yeah, but how do we know that? We need to go into what the chromatogram shows. Personally, I don't think that there is insufficient detail for M2. They needed to tell me that one of the spots, they had each had a spot at the same level, not just shared by them. That for me isn't good enough. It might be for some people, for me it isn't. So I wouldn't have given that mark if I'd have been marking. So I would only give 1 there. Okay, they can be certain about G, yeah, because it only has 1 spot. Notice that M1 says the student can only be certain about G containing 1 dye as only 1 spot. Now, the as only 1 spot or containing 1 dye as only 1 spot is not in brackets. So that means that they have to say something about there being only 1 spot. So they can't just say they can only be certain about G. They must also make a reference to the fact that there's only 1 spot. Okay, that's very important. The dyes in F form spots up the paper, do not form spots up the paper because they're insoluble. So mentioning they're insoluble scores the 2nd mark. So that kind of gets 2 marks. Okay. So that they do not dissolve in the solvent, scores M1. No results will show. I don't think that is sufficient for giving an indication that the dyes can travel up the paper. And no results will show for me is too vague. So I'm not prepared to award M2 there. So only 1 mark. Okay. E and H is correct as they share a dye as it climbs to the same level for both. I'm happy with that. Okay, that's a bit more detail than they just share a dye, which is what the student 1 had. So I'm quite happy for that one to get 2 marks. They can only be certain about G. Why can they only be certain about G? They haven't said they can only be certain about G because it's only got one spot. Okay, so as the mark scheme stands, they cannot have that mark. Although I have a sneaking feeling that in the real marking, they probably would have been allowed it. But as the mark scheme stands, if we're reading and applying the mark scheme as it applies here, then that mark should not be given. It may be that the principal examiner then later said, don't insist on containing one die as only one spot. Don't insist on it, even though it is on the mark scheme. And I'm fairly certain, and that's what the principal examiner would have said. But as it stands, they don't get that mark, okay? And then F did not move. And as I said, those marks are independent of one another. So M2 has to be given. So that candidate gets 1 mark. And then there's the final one. So that the inks don't dissolve, 1 mark. Allow inks for dyes. Okay, I know they've crossed out dyes and written inks. I think we can allow inks for dyes. Okay, and then the inks won't move up the paper down there, scores the 2nd mark. Okay, so that candidate scores 2 marks. No marks because F is wrong. So even though they've got one of the dyes traveling to the same distance, correct. It says in the notes column, M2 is dependent on M1, and they've got E and F instead of E and H. So they can't have the 2nd mark. So that candidate scores 0. They can be certain of F due to it not moving. Okay. F is wrong, of course, but as I said earlier, the marks, as the mark scheme stands, are independent marks, so they should be given F not moving mark, and so 1 mark. Okay, and the last one, to ensure the dyes do not dissolve in the solvent, scores M1. Okay, rather than go up the paper, that sort to me to indicate that if the dyes were placed above, they would go up the paper. It's a sort of reverse argument. And so I'm quite happy that these candidates realise that if the dyes were placed above the solvent, they would go up the paper. So I'm quite happy to give both marks there. E and H is correct because their spots travel the same distance is correct. So that candidate scores 2 marks. Since F was not separated due to it not moving, due to its insolubility, scores M2. G, on the other hand, moved, but displaying only 1 stain. Yeah, I think we can read stain for spot, so we can allow M1, and that candidate scores 2 marks. Okay. Right, I know that was rather quick going through those, but I hope you've been able to take in the points that I'm making there. And when you go back and remark these yourselves, I hope you should be able to get the same marks as I've achieved. Okay. The other bit here of this particular question was calculating the RF value. Okay, so they had to put down for the first mark some reference to 65 millimeters or 6.5 centimeters. Or 39 millimeters or 3.9 centimeters, and the RF value is 39 over 65 equals 0.6. Okay, accept any value between 38 and 41, accept any value between 0.56 and 0.64. They were told that the solvent level, by the way, was 65, so they have to get 65 exactly. M3 not awarded is if the value is incorrectly rounded. Okay, so let's have a look. There's your first answer. And I think we can see straight away they've got 6.5, which will be in centimeters, M1, 3.9, which is in centimeters, M2, and they've worked out the answer correctly, 3 marks. They don't have to put the units in, it's pretty obvious. 3.9, 6.5 is what we're looking for. Okay, we don't need it. We don't need the units here to award those marks. This is all about getting a calculation, okay? Does this candidate know what he or she is doing? And the answer is yes. Okay, there's the next one, 6.5 centimeters, correct. 4 centimeters is allowed because you can allow 3.8 to 4.1, so that scores M2. They've got the calculation up the wrong way, so that's wrong, so they score 2 marks. Next one, 4 centimeters scores M2 because it's within the tolerance. 2.5 is wrong, and they've done the calculation incorrectly. They've multiplied to divide, so they can only have 1 mark. Student 4, 6.5 scores M1, 4 scores M2, but 0.6 is wrong. Incorrect evaluation, 4 divided by 6.5 should be 0.62. Okay, which really ought to be given as an answer as 0.6. That's 0.62 would have been okay. All right, because you can see accept any value between 0.57 and 0.64. 0.67 is outside of that range. They've done that completely incorrectly. So 2 marks. Okay, teaching, doing practical work. Okay, the specification gives a number of practical activities that form part of the subject content. Exam questions expect students to be familiar with the methods for each of these practicals. They're listed in italics in specification. And as I mentioned yesterday, the ideal situation is that students do each of those core practicals, all 12 of them that are listed. That would be the ideal situation. They need to have a knowledge of all 12. Either by doing them, demonstrations, or seeing them on video. Questions expect students to be able to apply their knowledge of practical methodology to unfamiliar scenarios. Why should students do practical work? I think that's pretty obvious. One of the things, of course, is so they can answer the questions on AO3 in the exam, but also to support the theory, because the theory and the practical work support one another. So it gives them a better understanding of the theory work. It supports the theory work. How do students get knowledge or skills from the practical activities? Well, certainly from the core practicals, but what about the other practicals you do? Have a good look at them and make sure that they're getting useful knowledge and useful skills from those. And you're not just giving them practical work for the sake of practicals. Make sure that they're actually relevant and useful. When do you do practical activities? Before or after teaching the theory of the topic? Sometimes it might be useful to do it before and develop the theory from the results of the practical. I'll give you an example of that in a moment. Teaching approaches, fact versus investigative. Here's an interesting one. Why does copper turn black when heated in air using a Bunsen burner? You could tell them it turns black because it reacts with oxygen form copper 2 oxide, or they've learned as a fact. However, you could turn this into an investigation. What may have caused the black substance to appear? You would hope the students would say Bunsen flame or the air, because what you've done is you've shown them a piece of copper foil heated in a Bunsen burner going black. And so they might say, it could be the Bunsen flame or it could be the air. How could we find out which? Someone might say, well, heat the copper in a vacuum so there's no air around. Well, you can't do it, of course, because you can't light your Bunsen flame without any oxygen. Or someone might say, well, let's try heating it in a test tube so that it's not in contact with the Bunsen flame. So you could send them away, give them a piece of copper foil, tell them to pick up a test tube and go and put the copper foil in the test tube, heat it, and see what happens. And of course, they will come back to you and say, it's gone black. So it can't be the Bunsen flame, must be the air. Okay? So how can we find out which gas in the air is responsible? Someone in the group may suggest heat the copper in each gas separately and see in which one it goes black. But it's not really practical unless, of course, you've got oxygen cylinders, nitrogen cylinders, argon cylinders, and carbon dioxide cylinders. So, but what you could do is you could heat copper in a sample of air and find out which percentage of gas is used up. Because another statement in the specification says the students should be aware of the percentage of gases present in dry air. So if we can find out what percentage is used up, we should be able to identify the gas. And this, of course, is the experiment that you do with 2 gas syringes and a thin silica tube packed with little turn-ins of copper. And you have 100 cubic centimeters of air in one gas syringe and none in the other. And you pass the air over the copper whilst you heat it. And you'll see that the volume goes down from 100 to 80, so 20% is used up, so it must be oxygen. Here you can see that they've learned a lot more than just the fact that copper forms copper oxide, and that makes it go black. Okay, then you can follow up and say, well, if it's combined with oxygen, what must be formed? Copper oxide. And then, of course, it would lead into another experiment. How could we find out what the ratio is between the copper and the oxygen, and therefore find out the formula? So there's a lot of investigative work there. And the more type of those investigations you can do, the better. Okay, good. I'm glad it's gone wrong. This is an experiment I always did before I start rates of reaction. Add 1 mole of hydrochloric acid to each of 3 boiling tubes, leave one at room temperature, put a second in a water bath in a beaker around about 40 degrees C, place the third in the water bath around about 60. You're going to add 1 centimetre strip of clean magnesium ribbon to each tube and measure how long it takes for the magnesium ribbon to completely disappear. But before you do it, predict the order and then do the experiment. And of course, they will predict 60 first, 40 second, room temperature last. And when you do it, it often disappears first at 60 and last at room. That's often, they will predict it disappears first at 60 and last at room, but it often disappears first at room and last at 60. And the reason, of course, is the gas is given off so violently at 60 that the magnesium continuously lifts off the acid and falls back down, and to a lesser extent at 40. At room temperature, it sinks, and therefore it's in contact constantly with the acid. So it's a good experiment. Good, it's gone wrong. And now, what could we do to get valid results? Is there some way in which we could trap the magnesium beneath the acid at 60 and 40 so that we can get valid results, we can make a valid method, a valid procedure? I'm not so sure it's easy to do that, but at least you can talk about it in theory of what needs to be done to get valid results. Okay. The core practical guide I mentioned yesterday, I will mention it again here. It's available on the Pearson website, Pearson qualifications, International GCSE exams. Click on C and then click on chemistry, go to the linear specification, the linear qualification, and then go to teaching and learning materials, drop down menu, and you will find the core practical guide. Please have a good read of that. I talked through in detail about it yesterday. I haven't got time to do again today, but just simply encourage you to read it. Okay, what other support is available? Well, for the linear, you've got the specification sample assessment materials, exam materials, and teaching and learning materials, which is where you'll find that core practical guide. Okay, there's the link for it. That link is present on the PDF version of the slideshow that I've put in your resource pack. Okay, so if you're having difficulty finding it through like the drop-down links that I've mentioned, you can simply type that into your URL bar and up it will come. And that's the sort of thing you'll get under teaching and learning materials. There's all of those drop-down menus. Okay, so have a look through that information at your leisure. You'll find a wealth of information to help you with teaching this particular specification. Okay, and there's a similar one for modular. Okay, and remember that there are 2 separates. There's linear and modular. So if you're teaching modular, this is the one that you should go to. But bear in mind the teaching and learning materials on the linear one are also applicable to modular. So although there's only 5 in the teaching and learning materials for modular, The ones in the linear specification do apply to modular as well. So I advise you to look at the linear ones as well. Okay, that's what you get at the moment in the teaching and learning materials, course planner, getting started guide, International GCSE linear to modular specification numbering guide, and then International GCSE science mapping to the Pearson book. Okay, and scheme of work. To Pearson, to Cambridge assessment and Oxford AQA. So you've got a mapping if you've been using other awarding bodies, and you've got a scheme of work there. Okay, there is your subject advisor. Okay, and if you've got any questions at all about this qualification, including anything to do with the exams answers, the mark schemes, drop a line to teachingscience@pearson.com and Tim or one of his colleagues will answer it for you. Okay, there are a number of questions in the chat box, so whilst I'll leave that up there for you to look at. Okay, and I'll go through these. All right. Do questions given at the end of each topic in the Pearson book cover AO1 and AO2? I have never read the Pearson book, so unfortunately I can't answer that question. Okay, I've not got a copy of it. As questions given at the end of each topic in the book are much easier than the questions that appear in the exams. Okay, again, unfortunately I can't give you any advice on that. Cliff, if you have all Pearson Edexcel practical videos resourced, kindly share it with us. No, I don't have any. I looked them up myself, and yesterday I made a recommendation to go to the Royal Society of Chemistry website to get some videos. Okay, and also possibly YouTube, but be very careful with YouTube. There are some awful demonstrations on YouTube that do not demonstrate good practice. Okay. Royal Society of Chemistry, the Royal Society of Chemistry have actually put some of their videos onto YouTube. Okay, if you have got the funding, then I would suggest you join the Royal Society of Chemistry as a member, because it gives you access to all their resources. There's a tremendous amount of resources that I make use of when I'm actually writing training material for these sorts of sessions, either online or face-to-face. Okay, do they have to say vapor for M1? Oh gosh, going back to that question, no, they don't. Just simply it cools. Okay, and condenses is good enough. They didn't have to say vapor. Okay, I think I've answered all those questions. I suppose the next thing for me to ask is, have you got any more? Okay, and if you haven't, then we'll probably call it a day. Okay. You've raised a hand. Can you put your thing into the chat box because everything is muted? Okay, so put your question into the chat box, please. Okay, a couple of questions have come up into the chat box. Right, for modular assessment, does it mean students sit the paper 1 in grade 10, the other in grade 2? That's entirely up to you. When they sit them, they can sit. You could run this as a 1-year course. So, for example, if you had started teaching modular this September 2024, module 1 papers and module 2 papers will be set next May, June. So if you can teach everything inside 1 year, which I know some countries do, then they can sit both papers at the same time. Or you could decide to let them sit module 1 in year 10 and module 2 in year 11, or you could wait till year 11 to sit both. It's entirely up to you. Okay, right. All right, answered. The certificate is answered. I didn't receive it for module 1. Okay, I can't answer that, unfortunately. Okay. Right. questions? Okay, well, we've got to 11 o'clock, so I will now bring the session to an end. I click on the end slideshow, so that brings the session to an end. There is just one last question. Oh no, people are saying thank you. Well, thank you very much for attending. I hope that this has proved useful for you. Okay.